everyone! Welcome to today's class. I remain Dr. Bisayo Tokiti, and today I'll be taking you through another series of the statistics made easy class that is called Analysis of Time Series. If you are new here, please kindly watch and send me your comments, your questions. If you are already an existing customer, I welcome you to this series of analysis of time series, and I assure you that you will enjoy it. So come along with me as I show you the rudiments of analysis of time series. Thank you. Then here we go. Analysis of time series is the topic we have before us today. And what is time series? That's the first question that comes to our mind. I've tried to shorten some of the definitions and write something that is critical or some important elements of time series on the board. And I said time series is observing numerical data at different points in time, or studying data over a period of time for our own advantage. It could be production, it could be sales, it could be population, it could be imports, it could be exports, it could be profits. We just want to know the trend of events over a period of time. And we also say time series is a set of data pertaining to the values of a variable at different time. Then there is something very important that we need to know, that why do we do time series? Time series is to project into the future, to make estimates, to make estimation about the future, about our business, the profit, the sales. We have made a particular sales this month or this year. We are hoping in another 2-3 years, how do I make this better, or how can I estimate into the future? And we say the first thing about time series is to gather information from the past. There is no way we can procast or project into the future without looking at what has happened in the past or what is happening presently. So time series we said one of the most important tasks before many businesses is to make estimates about the future. An estimate about the future cannot be done without getting information from the past data. Then secondly, this can be achieved through statistical data, through collecting it, or collection, observing and recording, and that is called time series. Said, for example, we might want to observe sales, production, birth rates, death rates, population, imports or exports rates over a period of time. We said time is the most important factor in time series analysis, because every variable is related to time, which may be in years, in months, in weeks, in days, in hours, and we want to be able to make proper prediction about the future. Okay, we'll be looking at an illustration now, and this illustration is just to help us buttress the point that we're making on time series, that it's studying of data over a long period of time to predict the future. And this is just a simple analysis I've made on the board. Illustration 1 says the following are the figures of sales of a farm within a particular state or country, but this is within Nigeria, and these are the sales in thousand. We have the years and the sales in thousand. We have 2001, 2002, 2003, 2004, 2005, 2006, 2007, then 2008. In 2001, there was a sales of 50,000, or let's say 50 million. The sales are in million, 50 million, 50 million. In 2001, a sales of 50 million. In 2002, a sales of 52 million. In 2003, there was a sale of 57 million. In 2004, there was a bit of decline to 51 million from 57 million. Then in 2005, we have a sale, it picked up back to a sale of 54 million. In 2006, there was another increase of a sale to a sale of 58 million from 54 million. In 2007, then came the increase from 58 million to 80 million. That means about 12 or 22 million difference, 22 million difference. Then in 2008 came the root shock. There was also a decline, a sharp decline, and the impact was so much, from 80 million to 53 million. And we said there could be several reasons that are responsible for the increase and decrease of the sales over a period of time. If we check from year to year, from the year 2001, we don't have the record of 2000. That is why we are starting from year 2001. There was an increase, and that was why I've pointed the arrow up. Then the second year, there was also an increase from 50 million to 52 million. Then in the third year, there was an increase from 52 million to 57 million. That's 5 million difference. But some things happened in 2004 that we could not explain, and the sales dropped to 51 million, making a difference of 6 million. Then in 2005, it picked up again to 54 million. In 2006, there was also another increase to 58 million. In 2007, that was the mega sales year, that it increased to 80 million from 58 million. That's 22 million difference. Then all of a sudden in 2008, if you can remember, we had a lot of economic challenges. During year 2008, there was the crash in stock worldwide. There were a lot of depression, inflation, and like that. So sales fell to 53 million. And I said there could be different reasons that justify the increase, whether the increase or the decrease of these sales over the period of time. The causes could be change in taste, it could be change in habits of the people, it could be growth in population, it could even be economic conditions that are beyond our control, it could also be government policies and regulation, it could be pandemic like we just saw in the last year. Then it could be alternative product. Maybe some of your customers or majority of your customer now prefers an alternative product to that your product. So it depends. So, and I said analyzing all the various factors causing the increase or decrease of sales, population growth rate, profitability, it could be anything, we could be measuring anything. It is not limited to sales, are based on 4 components. And here we come the components of time series. The first one is called secular movement or trend. The second one is called cyclical variation. The third is called seasonal variation or variations. Then the fourth is called irregular or erratic variation. Starting with the first one that said secular movement. Secular movement or trend is a general tendency in the increase or decrease of data over a period of time. Then when we look at cyclical variation has occurred as a result of either a boom or depression within an environment. Then also we say seasonal variation. When we say season, it means it's seasonal. It has occurred within a period of 12 months or a speculated period of time. Now everybody knows we are in rainy season. After this rainy season, maybe after 6 months or 2 months, depending on the weather forecast, maybe we'll go into dry season. We have summer, we have winter, we have spring, we have harmattan, and like that. So seasonal variation, things that has repeated over a period of time. Then we also have irregular or erratic variation. And irregular or erratic variation, because of the word irregular or erratic, has occurred as a result of forces beyond our control, changes in forces beyond our control. Like the pandemic was beyond our control. That was the first time we were seeing something like that in this generation, though it was controlled later on. But at the first instance that it happened, there were forces beyond our control. Earthquake, flood, famine are all things that are classified under irregular or erratic variation. The next is to look at the importance of time series. And like I said earlier on, there are some important elements of the time series. And the first is what? It helps us to be able to understand history, the past behavior, things that has happened in the past. Then also, it also helps us to analyze what is happening at the moment. Then it also helps us to forecast the future. Then it facilitates comparison. it facilitates comparison. Then also there are models of time series. Basically there are two models of time series. The first one is called multiplicative model, and multiplicative model is multiplication of all the components of time series, where we have the secular, that is secular trend, that is T, we have the cyclical, we have the seasonal, and we have the irregular. It means T multiply by S seasonal, multiply by C cyclical, then multiply by I, that is irregular. Then we have the additive. The additive means adding up all the components of time series, where we have trend, which is T, we have seasonal, we have cyclical, and we have irregular. It means T plus C plus S plus I. Then measurement of trend. Now we are taking each of those components one after the other. The first one is called secular movement or trend. So we'll be starting with trend before going into seasonal, before going into cyclical, and before going into irregular. The first one we'll be looking at is measurement of trend. And why do we measure trend? For two basic reasons. One, to find out the trend characteristics. Trend means a pattern over a period of time. Then also to enable us study other elements like seasonal, cyclical, and irregular variation. Then what are the methods of studying trend? From my textbook, I've discovered 4 methods of studying trend, and the first one is called the freehand or the graphic. It can also be called graphical method because it has to do with drawing graphs and like that. Then the second one is called the semi-average method. Then the third one is called the moving average method. Then the last one, which is not the least, is called method of least square. We'll solve one after the other: the freehand method, the semi-average method, the moving average method, the method of least square, one after the other in the next slide. We are starting with the first method of measuring trend, and which is called the freehand method or the graphical method. This is the simplest of all the methods of measuring trend, and it is done by 1, plot the time series on a graph. This is the question on the board. Then 2, examine carefully the direction of the trend based on the plotted information. Then thirdly, draw a straight line which will best fit the data according to your personal judgment across the points on the board. Then this is illustration 1, and illustration 1 say fit a trend line by a freehand method. We have the year, we have the profit in million from 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009. Then the profit in million, we have 20 million, 22 million, 24 million, 21 million, 23 million, 25 million, 23 million, 26 million, and 25 million. And we are supposed to represent this by freehand or graphical method. I do the solution on the next page of the board. And the first thing is, we know we are drawing a graph on a straight line. We are drawing a graph on a straight line, and usually when we draw a graph like this, this is called the x-axis. This is called the x-axis. This is called the point of origin, and this is called the y-axis. X-axis, y-axis, and the point of origin. And from the data, the year is always, or production or sales or variables are always represented on the x-axis. Then the values, profit, sales, margin, anything that has value is represented on the y-axis. Then I'm representing the years now on the x-axis. We start from 2001. So I say 2001, 2002, 2003, 2004, 2005, 2006, 2007. I'm going to clean up because the space is not going to contain it, so I'm going to clean up for a proper spacing. So the first one says 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, then 2009. I think this is better than the first one. Then putting in the figures. Imagine starting from 0, we have 20, 22, the lowest is 20 and the highest is 26. So what's going to be my margin? I'm going to make 20, 40 and like that to be my margin. So I'm going to start from 0. So the first value will be 20, my next value will be 40, then the next value will be 60. We call this scale. So I'm using a scale of 20, 40, 60 and like that. So I'm starting with the first value, and the first value, I think this 40 is too high, so let me try to bring it down a little. This 40 is too high. So okay, so I'm starting with the first value. For 2001 we have 20, so I'm coming to where 2001 is. I'm marking out 20 on the board, just the point where it intersects 20 and 1. So I'm going to come here and mark out 20 on the board. For year 2002 we have 22. 22 will just be a little above 20 because we are not drawing on a graph book, so we are not expecting accuracy, just for us to understand what I'm doing. So 22 will be a little above 20. Then the next one says 24. 24 will be above 22. The next one says 24. 24 will be above 22. Then the next one, 2004, says 21. 2004 says 21. 21. 2004 says 21. 2005 says 23. 2005 says 23. 2005 says 23. 23. Then 2006 25. 2006 25. 2006 25. 2007 23. 2007 23. 2008 26. 2008 26. It will be a little above 25. Then 2009 25. I come again and point out where 2009 and 25. It means I'm trying to trace it to the y-axis, the x-axis and the y-axis. If I'm to mark it out, I'll just draw a line across it like this. I'll draw a line across each of the values like this, but it will make my rough work to be rough. That's why I'm not drawing a line across. It's just where it intersects. That's where the point will be, where it intersects. That's where the point will be, where it intersects. That's where we'll put our point. Then this will be 20, so I'm going to put it back here. This will be 20, and the rule says 1. Plot the time series on the graph. Examine carefully the direction of the trend based on the plotted. Draw a straight line. So the first thing we'll do is we'll draw a line that joins all the points. We draw a line to join all the points. So I'm starting from the first one and I go like this. I want to join all the points together. I want to join all the points together. I want to join all the points together. And the last one, then this is called the actual line. 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 Then we draw a straight line which will best fit the data according to your personal judgment. According to my personal judgment, I'll just draw a straight line across the graph. I'm going to draw a straight line across the graph, and this line is called the trend line. 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 There are some limitations, merits of the freehand method that will be on the next page of the board. Okay, still on the freehand method. The freehand method should try as much as possible. When we are using the freehand method, we try as much as possible to conform with the following conditions. 1, let us try as much as possible to make our lines to be straight, whether we are trying to join the curve or we are drawing a straight line across the curve. Then secondly, the sum of the vertical deviation from the trend of the annual observation above the trend should equal the sum of the vertical deviation from the trend of the observation below. That is, the value above should equal the value below. Then what are the merits and limitation or demerits of trend? 1, if you are talking about the merits, is one of the simplest method of measuring trend. Then it is also very flexible because personal judgment is required. Then also it is widely used in applied situations, but it still has its own limitations. And what are the limitations? It is highly subjective, and because it is subjective, it cannot have much value that will be used for prediction. Then also it could be time consuming, or it is time consuming. As we move on, the next method of measuring trend is called method of semi-average, and these are some basic principles that will guide us in solving the illustration on the board. The first principle says the data is divided into two parts, and the average of each part is to be obtained. What it means that no matter the values of years that they have given you, divide the years into two equal parts. From the board we can see we have 2000, 2001, 2002, 2003, 2004 and 2005, making 6 years, and I've divided them into two equal parts: 2000, 2001, then 2002, 102, 105, 114. Then find the average divided by 3 because it's 3 years. Then the second one, 112, 108, 116 divided by 3, finding the average. So that is 231 divided by 3 is equals to 107. Then 336 divided by 3 is equals to 112. Then the second one says each point is plotted at the midpoint of the class interval covered by the respective parts, and then the two parts are joined by the straight line, which gives us the required trend line. Then the line can be extended downward or upward to get intermediate values or to predict the future value. But somebody might ask, what if we have an odd number, 7 years, 9 years, years that cannot be easily divided by 2? If, for example, we have 7 years on the board, what we do is either, there are two ways to go about it. The middle value, the middle year, is either we divide it into two equal parts. We add the half to the one on top, and we add the half to the one on that. But the most appropriate is to ignore that year. The most appropriate is to completely ignore that year. But because of the example of the board, we have just 6 years, and I've taken the first step to divide it into two equal parts. This is the first part, part A, and this is the second part, part B. And part A is 2000, 2001, 2002, and their sales is 102, 105 and 114. Part B is 2003, 2004, 2005, and the values are 112, 108 and 116. I've added each of the parts together and taken the average. The first average is 107 and the second average is 112. Then I want to plot it on this graph, the actual value, then also to get the trend line. So I start for the year 2000, year 2000, I've indicated it on the x-axis and on the y-axis. For the year 2000, we have 102. 102 is just a little above 100. 102 is just a little. Don't mind my board, it is so small. Please just manage. The most important thing is we understand what I'm talking about. Then for year 2001, we have 105. Year 2001, we have 105. Year 2002, we have 114. Year 2002, we have 114. Year 2003, we have 112. Year 2003, we have 112. Then year 2004, we have 108. 108. Year 2004, 108. Slightly. Then year 2005, we have 116. 116 is above 110, so I'm going to take it above 110 before 120. I'm going to draw a line to meet all the points. So I'm starting from this point, drawing a line to meet all the points, drawing a line to meet all the points, drawing a line to meet all my points. And he said, based on personal judgment, draw a straight line across it. Draw a straight line across it. This is called the trend line. This is called the trend line. This is called the trend line, and this is called the actual line. This is called the actual line. But it doesn't stop there. We can also get our values, these values from the board. Let's look at 107. Where is 107 here. Where is 107? This is 100 and this is 110. So 107 will be around this point. 107 will be around this point. Then bringing it to the line. Let's see where it joined the line. Let's see where it joined the line. That is year 2001. Then let's look at 112. 112. This is 107. Then 112 is above 110. 112 is above 110. Slightly above 110. Slightly above 110. Slightly above 110. Then bringing it down. Bringing it down. That's year 2001 and year 2002. Year 2001 and year 2002. We are going to look at the merits of semi-average and some of the demerits. One of the merits is simple to understand, everybody can understand. Then secondly, it is objective compared to the other method that was subjective. Then what are the limitations? One of the limitations is that trend values obtained are not precise enough. Then also it assumes a straight line relationship, whether a relationship exists or not. Third method we'll be looking at is called method of moving average. Then it comes with its own principles, its theories, guiding rules and regulation. And it says the average value for a number of years is secured, and the average is taken as a normal or the trend value for the unit of time falling at the middle of the period covered in the calculation of the average. It has some merit and limitation. One, the merit is simple to understand and it is objective compared to the other one that was subjective. Then limitation, sometimes or in most cases we lose some year at the beginning and we also lose some year at the end. Then also there are no mathematical rules guiding this, so that is also a limitation rather. Then the illustration says calculate the trend using 3 yearly and 4 yearly average. I will do the illustration on the board, just come along with me and I'm sure you understand. The first one says the 3 yearly total. It means that year 2001, 2002, 2003, 2004, 2005, 2006, 2007. And since we are looking for the 3 year total, the instruction says since it is 3 years, we are taking the average of 3 years. The average of 3 years starts with 2. That is, we have 1, 2, 3. The middle value is 2 years. So the first value we'll be putting on the board will start from 2, number 2. The first value, this is number 1, this is number 2, this is number 3, this is number 4, this is number 5, this is number 6, and this is number 7. The first value that we'll put on the board will start from value 2. That means the first one will be dash and the last one will be dash, because it's a 3 year moving average and the average of 3, the middle of 3 is 2. So the first value we'll be putting here starts from 2. And how do we go? The first line says the total, so we start with the first value. 7 plus 9 plus 11. 7 plus 9, 3 years, and 11 plus 9 is 20, plus 7, that's 27. So the first one will be 27. The first year will be 27. I'm going to move 7 out. I don't want to cancel because I'm going to use it for the 4 year moving average, so I'm supposed to cancel it out. Then the next column says 3 year average, 3 yearly average. What is the average? It means 27 divided by 3. 27 divided by 3 should give us 9. 27 divided by 3 should give us 9. That means 3 plus 3, 6, plus another, then another 3 should give us 9. I'm trying to see if it's actually right. Then the next one, another 3 years, will be 9 plus 11, that's 20, plus 14, that's 34. So come here and write 34. 34 divided by 3, we have 1. 3 divided by 3, we have 1. Then 3 in 4, we also have 1. But remaining 1, so add 0 to it. 3 in 10, that will give us 3. 3 in 10 will give us 3.3.3.3. Then we'll circle out the second one too. We start with the third one. 11 plus 14 plus 13, that is 38. This is 25 plus 13, that will give us 38. So I come here and write 38. 38 divided by 3. 38 divided by 3, I have 1. Then 3 in 8, I have 3 in 8, I have 2. Remaining 2. Then 3 in 20, 6 and 6 and 6 and 6, like that. Then I circle this third one out too. The next one is 14 plus 13 plus 12. So 14 plus 13, I have 27. 27 plus 12, I have 39. So the next one will give me 39. Then 3 divided by 39, I have 1 and I have 3. So I'm going to circle out the 14, the other one too. Then the last value says 13 plus 12, that's 25, plus 10, that will give me 35. That will give me 35. 35 divided by 3. 3 here 1, 3 in 5 1, remaining 2, 3 in 20, that's 6. So I'm done with this 3-year moving average. I take again for you better understanding. Since it's a 3-year, this is 3 yearly total and 3 yearly average. The first thing we do is we take the first 3 years and add up. Once we add it up, 7 plus 9 plus 11 is 27. Is 27 divided by 3. We have 9. Then we cancel the first value out, like 7, and take the next 3. 9 plus 11, that's 20, plus 14, that's 34, and 34 is here, divided by 3. Then we take 9 out and say 11 plus 14, that's 25, plus 13, that's 38, divided by 3, 12.6. We take 11 out, then 14 plus 13 plus 12, that will give us 39. 39 divided by 3, we have 13. Then the last one, after taking 14 out, we say 13 plus 12 plus 10, that will give us 35. 35 divided by 3 is 11.6. The same principle applies to the 4-year moving average or 5-year moving average, 7-year moving average. The same principle that we have applied for 3-year moving average is what we apply for 5-year moving average, 7-year moving average. We start from the midpoint, the middle value. If it's 5 moving average, the middle value is 3. So we are starting, the first value we are putting will be from 3. If we are looking at 7 years moving average, the middle of 7 is 4. 3 up, then the remaining 3 down. So 4 will be our center. So we are starting our first value from 7. But for a 4-year moving average, it is slightly different. And why is it different? For even numbers, when it comes to even numbers moving average, they are slightly different from odd numbers. Odd numbers follows these principles of 3 years moving average and 3 years total. But for even number, it is slightly different, and I do similar illustration on the board. Because it is 4 years, once we divide into 2 equal parts. We say 1, 2. Sorry, my marker, I have to change it. Since it is 4 years, we say 1, 2, 3, 4. If I try to divide into 2 equal parts, it means it is in between. The value is in between. The value so it means that any value we are slotting it, the first value will be between 2 and 3. The next one will be between 3 and 4, and like that. I hope we understand what I'm talking about. Let me just do a simple illustration on the board using the same figures that we have used. This is now 4 years moving average. 4 years moving average. This is 4 years moving average. 4 years moving average, no longer 3, it's 4 years moving average. So I assume the first and the second value are dash. So I'm going to start from in between the second value and the third value. The second value and the third value. This is the second value. So the in between the second value and the third value is here. So I'm going to add the first 4 values together. I'm going to say 7 plus 9 plus 11 plus 14. That will give me 27 plus 14. That is 37. Then that is 41. So my value here is 41. The value will be between 3 and 4. The value will be between, the first one will be between 2 and 3. The first one will be between 2 and 3. The first one will be between 2 and 3. These markers are not writing well. The first one will be between 2 and 3. I think I got 20, 27, 41. I got 41. So it will be between 2 and 3. The first value will be between 2 and 3. Then 4 divided by 41. 4 divided by 41. What do I have? 4 divided by 41. 4 in 4, 1. Then 4 in 0. 4 in 1, 0. Then 4 in 10. Then 4. So we have 10.4. 10.4. 10.4. Then I move on to the next value. I'm going to cancel out 7 now. I take the next 4 values. 9 plus 11 is 20. 11 plus 20 plus 27. 20 plus 27, that's 47. So the next value will be 47. The next value will be 47. The next value will be 47. My next value will be 47. The next value will be 47. Then 4 divided by 47. I have 1 here. Then 4 in 7 is also 1. The remaining 3. 4 in 30. 4 in 30 should give us 7. 4 in 30 should give us 7, and like that. Then I take 9 out and multiply the next 4 values and add up the next 4 values. 11 plus 14, I have 25. 25 plus 25, I have 50. So the next value would be 50. The next value, my next value will be 50. I hope the camera can see this. The next value will be 50. Then 4 divided by 50. 4, this is 50. 4 divided by 50. 1, remaining 1. 4 in 10, that's 2. 4 in 10, that's 2, remaining 2. 4 in 20, that's 5. 12.5. I am taking out, I'm taking out 14 now. I'm taking out 14, or I think it's 11 I'm taking out now, or 14. I can't remember the ones I'm taking out now, but the last 4 digits. 14 plus 13. 14 plus 13, that's 27. Plus 12, that's 39. Plus 10, that's 49. So I come here and put 49. I come here and put 49. I come here and put 49. 49 divided by 4. 49 divided by 4, I have 1 in 9. I have 2, remaining 1 in 10, 2 points there after. So I hope we are able to understand what the 3-year moving average is and what the 4-year moving average is. We go to the last method, which is the method of least square. The next and the last method, but it's not the least method, that we'll be looking at is called the least square method, or eliminating trend. And this method came about because of some other limitations of the other methods we have seen in the past, and it is also called the best fit method. That is, the estimate of the construct of A and B are the best linear unbiased estimates of those constants. And we all know that the trend line is always represented by y is equals to a plus bx, and we can do a and b, y and x are constants. A and b are what we have to determine. Are what the variables that has to be determined. Then in determining a and b, the formula is summation y is equals to an plus b summation x, and summation xy is equals to a summation x plus b summation x squared. This is called equation 1. This is called equation 1, and this is usually called equation 2 using simultaneous equation. But on the other hand, if we don't want to use simultaneous equation, especially when summation x is equals to 0, we can also use this method. And note that we said y is equals to a plus bx, that's the regression line. Then bringing a out, a will be equals to y minus bx, then b will be equals to y minus a all over x. Then a is equals to summation y all over n, and b is equals to summation xy all over summation x squared. I'll do a simple analysis or illustration on the board to base these theories or this formula on, so that we would have a clearer understanding of what we are talking about. An illustration on the least square method or eliminating trend. And the question says, eliminate the trend from the following data, taking a deviation, that is our base year, from 2008. And if our base year is from 2018, rather 2018, the base year is from 2018, it means our base year would be 0. Our base year would be 0. Our base year, taking year 2018, sorry, I want to pick a paper from this table. Taking the year 2018 as our base year. Don't forget I said we have 2015, 2016, 2017, 2018, 2019, 2020, 2021. The numbers of years that we have, 1, 2, 3, 4, 5, 6, 7, is 7 years. Then unit of production, which is represented by Y, for 2015 we have 125, for 2016 we have 128, for 2017 we have 133, for 2018 we have 135. Don't also forget that 2018 is the base year starting from 0. Then for 2019 we have 140, for 2020 we have 141, then for 2021 we have 143. Because 2018 is the base year, going up it will be minus, coming down it will be addition. So we assume that we say that 2019 will be 1 because this is 0. 1, 2, 3, and going up this will be -1, -2, -3. I hope we understand. Let me take it again. Any year that we have been given as the base year, sometimes they might not specify. If they don't specify, it means we have to solve it out using that formula of simultaneous equation where we have equation 1 or equation 2. But if they have specified that so year is the base year, it just means you come to where the year is and write 0. They've taken deviation from 2018, put 0. As you go up, minus it up, it goes up, that is subtraction. As it comes down, that is addition. You start adding 1, 2, 3, depending on what you are doing. If we try to add this up, this will give us 0. Then the next column say x squared. X squared minus 3 times minus 3 will give us 9. Minus 2 times minus 2 will give us 4. Minus 1 times minus 1 will give us 1. 0 times 0 will give us 0. 1 times 1, 2 times 2, 4, 3 times 3, 9. Adding this together, this is 20, I think 28 if I'm right, 28. Then the next column says x and y. X and y, it means multiply this column with this column. So 3 times this will give us 3 minus 3, 7, 5. 2 times 1, 28, will have minus 2, 56. Then 1 times minus 1 times 133 minus 133. Then 0 times 135, we have 0. 1 times 140, we have 140. 2 times 141, we have 282 if I'm right. Then 3 times 143, we have 429. Adding all this together, the best way to solve this is add 429 plus 282 plus 140. Adding it together, this is 11, remaining 1. This is 15, remaining 1, and this is 6. Then this is 8. 6 plus 2, that's 851. Then minus this to would tell us what we need. 851 minus 355. What do we have? 1. If we borrow, we have 1. If we add 1 to it, will give us 6. Then this will be 4. If we add 1 to it, will give us 14. This will be 7. This will be 7 minus 3, that's 4. 473 minus 256. This will give us 0. This will give us 2, and this will give us 2. Then 220 minus 3. This will give us 7, and this will give us 11 minus 3. That will give us 8. So our total year would be 85. I'll be 87 rather. 87. The total year will be 87 from my calculation. So it's just a simple analysis. What we do is add up this together, then subtract the minus sign. The total answer is 87. Bringing it back into the formula says y is equal to a plus bx, and a from the previous formula I gave us was summation y all over n. Summation y on the board is 945. So 945 divided by n, the number of years, that's 7. That is equal to 135. Then B is summation xy all over summation x squared. Summation xy on the board is 87, and x squared, summation x squared, summation x squared is 28. 87 divided by 28, we have 31.07. Bringing it into the regression equation, we have y is equals to 135 plus 31. The last thing we'll be looking at today is not the last one of the things again that we'll be looking at today are how to measure other variation like seasonal variation, cyclical variations, irregular fluctuation, and like that. For seasonal variation, measurement of seasonal variation, one, what are the methods? There are 4 methods like measuring trend too, and the first method is method of simple average. The second method is ratio to trend method. The third method is ratio to moving average method, and the fourth method is link relative method. But for the cyclical variation, the measurements are 1 residual, the second one is reference circle analysis method, then the third one is the direct method, then the last one is the harmonic analysis method. I hope you have learned 1 or 2 things from the illustrations today of time series analysis. If you have any question or if you have any comments, you want me to work on any topic, please don't hesitate to put it in the comment section below. I'll be willing and I'll be glad to answer such questions and to respond to all your comments. I really appreciate you for watching this video, and I say big thank you and God bless everyone. Don't also forget to subscribe to my channel. God bless you.